All right, guys, so we are continuing with Unit 3. Today's going to be a pretty hefty day. We're starting to talk about different kinds of statistical studies. And I'm just going to be frank with you, there's a lot going on here. You can just see from this list of vocab words here, there's a lot going on here. The vocabulary terms, what I would suggest to do, I'm not going to take the time to write them out because I don't think that would be very helpful for you. My suggestion would be to make some flashcards with these. They are in the front of your packet. And so that would be my suggestion, to maybe even stop the video and go and study those vocab words first before I start using them like interchangeably, a lot. All right, so let's get started. All right, so we're talking about the design of experiments here. All right, so here's an example. You want to test if a special diet, exercising regularly, or a combination of both is effective in women over age 50 that want to lose weight. You have a random sample, so that's good, of 40 women over the age of 50 for your study. Identify the following key terms in the situation. All right, so the experimental units, this is like who or what are we trying to study. This is these 40 women over 50. They are the people that I'm trying to study. My response variable, like what am I actually measuring about these women? Well, I'm measuring their weight loss. All right, the factors and levels is honestly kind of the most tricky part. But think about it like this. I'm either going to assign people to be in a diet or exercising. Now, I could assign people to do the special diet, or I could assign them no diet, kind of like a control group, where obviously I wouldn't expect them to lose any weight if they're not on a diet. Exercise, I could assign people to do regular exercise or no exercise. All right, so when we're looking at these over here are the factors, and these over here are my levels. All right, so my treatment groups is going to be like combinations of these levels. Like what am I actually assigning to people? So I just kind of need to pick some. So I could assign somebody to special diet and regular exercise. So the combination group, diet and no exercise. Or sorry, diet and exercise. Regular exercise, what I meant to say. I could do diet and no exercise. So just the special diet group. I could do another group that's no diet and regular exercise. And then a group that is no diet and no exercise. So I have 4 treatment groups here. Now, the treatment group that I assign nothing to, basically, you can think of it like that, or I'm assigning like a fake treatment. Here, I don't really have a fake treatment, but here I do have a group where I'm assigning nothing to. And this group would be my control group, right? I wouldn't expect those women in that group to suddenly start losing weight, right? Because they're not on a diet and they're not exercising regularly. So they're my control group. I would expect nothing. It gives me a baseline to compare the other groups to. All right, how have we controlled potential confounding variables? Confounding variables means like other variables that are causing, like other things that could be causing these women to lose weight other than diet and exercise, right? Could be, I don't know, something else, genetics or whatever, stress or, their job is physically demanding or something like that. Well, the two main things that we do in experiments are having a control group and then we do random assignment into treatment groups. Those are kind of the two main ways we help control confounding variables. All right, the last question, isn't it possible to include blinding in our study? Blinding would mean that either the facilitators of the experiment or the participants in the experiment don't know which treatment they're getting. And the treatments are diet and exercise. So if I put you on a diet, it'd be kind of hard. I mean, it'd be impossible for you to not know that you're on a diet, right? And if I assign you exercise, obviously you're going to know you're exercising. So no, it is not possible to make this blind. Because you're going to know. All right, like I said, it's going to be very important that you understand these vocab words. This is a vocab heavy unit here, and my suggestion would be to make flashcards here. All right, let's do a practice problem. All right, so same thing here. You look at this osteoporosis problem. Pause the video for roughly 8 minutes or so and figure out the same thing. Experimental units, what's the response variable, factors and levels, treatment groups, and then any problem that you might see with the experiment here. Little curveball at you. All right, so 8-10 minutes. I'd pause the video and I will show you the answers. All right, my experimental units here are the 20 men aged 60 to 69 and the 25 women aged 70 to 79. My response variable is the change in bone density. My factors here, are men and women. So it's not really something I'm assigning, obviously. It's kind of like how I'm splitting people up. You get to give it like that. And then the levels would be I'm either giving them a supplement or a placebo. Okay, so I have 4 treatment groups. Male and supplement, male and placebo, female and supplement, and female and placebo. All right, so we've kind of stratified the groups here where these two groups would be the control group. All right, and then a problem you could have here is, it might not be a problem, but it could, is the men and women are different ages. They're not off by much, but I don't know anything about osteoporosis. It might actually be significant enough to cause a problem. All right, so let's talk about a little bit more about blinding real quick. Some people who race greyhounds give the dogs large doses of vitamin C in the belief that dogs will run faster. You have a random sample of 15 greyhounds and 2 vitamin C supplements, 250 milligrams and 500 milligrams. Explain how you incorporate blinding into the experiment. Okay, well, it's pretty easy to make it blinded for the greyhounds, right? Because they're not aware, like they're not consciously aware of what they're eating, right? So you could slip it in their food or just give them the pill, right? And that they're not going to know. Another thing that you might want to make it blind to is the owners of the dogs, or the people who are racing them, because they might, if they know that their dog is getting a large dose of vitamin C, they might do something different, and that doing something different would be a confounding variable here, which is going to cause problems. So sometimes blinding is possible, sometimes it's beneficial, sometimes it's impossible, and it just, you kind of got to take the bad with the good there. Okay, so that's an experiment. We doing research on experimental units. We have split them up into factors and levels. We're assigning people to treatment groups. All right, the next kind of study is an observational study. This is a study without random assignment. We don't have treatment groups, and we're not randomly assigning people to them. We're literally just watching people and measuring something. The key difference also between an observational study and an experiment is an observational study, we can only determine correlation. Right? An experiment, we can determine cause and effect. But keep in mind, correlation does not equal causation. It's not the same thing. Just because two variables are related to one another does not mean that one is causing the other. All right, so let's look at an example of an observational study. Baby walkers are seats that hang from frames that allow babies to sit upright with their legs dangling and feet touching the floor. Walkers have wheels on the legs that allow the infant to propel. Yeah, I mean, you've probably seen these if you've been around babies at all. Typically, they use them between 4 and 11 months. Because most walkers have tray tables in front and block the baby's view of their feet, child psychologists have begun to question whether walkers affect infants' cognitive development. One study compared mental skills of a random sample of those who used walkers with a random sample of those who never used walkers. And they measured mental skill scores averaged 113 for the babies who used the walkers and 123, slightly higher, for the babies who did not use the walkers. All right, so identify the explanatory and response variable in the study. Remember, this is kind of like X and Y and from the last unit. The explanatory variable is the independent variable. Right, so think of it. Do we think that the use of a walker depends on the mental score, or the mental score depends on the use of the walker? Definitely that second one. That's definitely what they're implying here. They're definitely saying that the explanatory variable would be walker or no walker, and then that would explain the baby's mental score, right? Or I should say mental skill score. All right, suppose that a study found a statistically significant result. Like, wow, this really does. There does seem to be a correlation between the use of walkers and a lower mental score, right? Would it be reasonable to conclude that using a walker causes a change in mean mental score? Keyword here, causes. No. Because this is an observational study. We are not assigning babies to treatment groups. Now, we could make this an experiment very easily. Randomly select babies and randomly assign them to the use of a walker or no walker. Right? But the key is we have to have that random assignment there. And if we don't have that, then we can't determine causation because it's not an experiment. All right, now what we're going to get into is when we're doing experiments, how do we actually do the random assignment, right? Kind of how we did sampling methods. How do we actually randomly assign people into treatment groups? And just like you probably guessed, there is a very precise process for this. Okay, so the first kind of random assignment is called completely randomized design. This is kind of like an SRS. You could kind of think of it like that. It's kind of similar. So I'm going to draw a little diagram here to kind of help you think through what I mean by that. So we have the experimental units, and all we do is we randomly assign them to treatment group 1, treatment group 2, treatment group 3, and so on, like however many treatment groups there are. So just kind of like an SRS, my step number 1, number the experimental units 1 through n. Step number 2, use a random number generator to assign EUs, the experimental units, to treatment groups. And then step number 3, measure the response variable, whatever it is. Pretty straightforward, just like the SRS. Except I'm not randomly picking people. I've already picked them. I'm randomly assigning them to treatment groups. Now, you can kind of connect this with the last lesson. The reason I need to have that random assignment to determine causation is because when we're talking about experiments, for the most part, people have to volunteer for these kinds of things. And when people volunteer for things, we have voluntary response bias, which we already talked about, creates problems. So when people volunteer, we get around that by randomly assigning them to treatment groups, and now they don't get to pick where they're at, and now I can control any other confounding variable, and I kind of reduce that bias a good amount. All right, so let's look at an example and see how we would do completely randomized design, or CRD is kind of the abbreviation. That's a bad R. There we go. All right, you want to test if a special diet. All right, so this is just the weight loss one. You have a random sample of 40 women, right? All right, so we just did this a second ago. All right, my EUs. I had 4 treatment groups: diet and exercise, only diet, only exercise, and then I had nothing, which was my control group. All right, so step number 1, number the women 1 to 40. Step number 2, use an RNG to assign. All right, so I got 40 women and 4 groups, so I'm going to assign 10 women to each of the treatment groups. Now I'm just writing treatment groups here because I've already identified what the treatment groups are over here. If you don't do this part, then in your listing here, you need to list out what are the actual treatment groups. All right, step number 3, response variable was weight loss. All right, so flip over to the next page. I want you to try this multiple choice question here. Which of the following situations correctly describes a completely randomized design? All right, take about 2 minutes, kind of a lot of reading there. Choose the correct answer, and then I'll show you in just a second. All right, the correct answer here is D, both 1 and 2. Number 3, there is no random assignment into treatment groups. You're just randomly selecting people, telling them to do one thing one night and then one thing another night. That's not the same thing. That's completely randomized design. Okay, so that's the first kind of random assignment into treatment groups, just completely randomized design. As you might have suggested, there are of course more. All right, the next one is called a blocked randomized design. When you think of this one, when you see blocks, you should think groups. And with that, you should think this is similar to a stratified random sample. We are blocking people into homogeneous groups. Remember, they're like grouped based on similarities. All right, so when I design my experiment here, okay, so I have my EUs and I split them however I'm blocking them. I have block 1, block 2, block 3, so on. And then within each block, I'm assigning all of the treatment groups. So let's say I had 3, treatment 1, treatment 2, treatment 3, treatment 1, treatment 2, treatment 3. So like each block is kind of like its own mini experiment. And remember, you can block by all the things that we did stratified random sampling by: gender, age, race, income level, experience level, like all kinds of things like that. Gender and age and race are really popular, especially when we're talking about like medical experiments. If you got the COVID vaccine experiment trials, human trials, were a blocked randomized design by age, because you can kind of see like how they released the COVID vaccine by a certain age group. That was a block design. They were blocking by age here. All right, so my steps. Number 1, well, first we need to identify the blocks, like what are we blocking by, just like in stratified random sample. Step number 1, number 1 through n in each block. Blocks don't have to be the same size, that's okay. Use an RNG to assign n people to each treatment group within each block. And then step number 3, measure whatever the response variable is. All right, let's do an example problem. All right, as dogs age, diminished joint and hip health may lead to joint pain and thus reduce a dog's activity level. Such a reduction in activity can lead to other health concerns such as weight gain and lethargy due to lack of exercise. A study is to be conducted in which to see which of the 2 dietary supplements is more effective in promoting joint and hip health and reducing the onset of canine osteoarthritis. Researchers will randomly select a total of 300 dogs from 10 large veterinary practices around the country. All of the dogs are more than 6 years old, and their owners have given consent to participate in the study. Changes in joint and hip health will be evaluated after 6 months of treatment. All right, so part A, what would be an advantage to adding a control group in the design of this study? Well, for every single study, the benefit of adding a control group is to give us a baseline to compare to. All right, so adding a control group would give us a baseline of comparison for the other treatment groups. All right, assuming a control group is added to the two other groups, so the two supplement groups, explain how you would assign 300 dogs to these three groups using a completely randomized design. All right, so let's set up kind of like our little diagram here. My experimental units here are dogs, and I'm adding them to the three different treatment groups. So I've got the glucosamine, chondroitin, however you say that, and then my control group. All right, so step number 1, number the dogs 1 through 300. Step number 2, use an RNG to assign 100 dogs to each treatment group. And then step number 3, my response variable, what am I actually measuring? Changes in joint and hip health. All right, so that's a completely randomized design. All right, rather than using a completely randomized design, one group of researchers proposes blocking on clinics, and another group of researchers proposes blocking on breed of dog. How would you decide which one of these two variables to use as a blocking variable? All right, so you're trying to think of like which one would seem more helpful. If we're testing medicine, right, a supplement, it seems to make more sense that blocking on the breed would be more significant. There's not going to be a whole lot. Remember, we need to block based on homogeneous traits. There's not going to be not a lot of homogeneous traits of dogs in just one clinic. There could be various ages, various there could be like a wider range of ages of dogs, a wider range of breeds, it just could be like health problems. It could be a lot of different things here. So blocking on breed makes more sense. For what I just talked about. We can block on a homogeneous trait and deal with the potential confounding variable of breed. If I block based on clinics, I might get to the point in my study where I say like, well, there's not really that much of a difference, and it's because there was various breeds at each of the clinics, and it messes up my experiment. All right, so part D says, all right, so now design the experiment based on which the blocks that we've just decided on. So breed. All right, so I've got to set up my diagram here. My experimental units are dogs, and we're blocking on breed, so come up with a few examples. Poodle, lab, etc. Like other types of dogs. All right, and then in each block, we would assign the 3 treatments. So the glucosamine, the C1, and the control group. G, C, control group. And so on. right, so my steps. Number one through N in each breed. I'm saying 1 through N here because I don't actually know, obviously, how many dogs are in each breed. They just told me 300 dogs total. Step number 2, use RNG to assign 1/3 of each breed to each treatment group. Now I'm using 1/3 because I don't know how many dogs are in each breed, obviously, like we just said. So I'm just going to say I have 3 treatment groups, so just assign 1/3 of them. This is totally fine on the AP exam. And then my response variable, measure the same thing. Changes in joint and hip health. All right, so that's what completely randomized design and experiments using blocking looks like in practice. I want you to flip over to the next page and do a practice problem now on your own, where they actually just give you the treatments here. You don't even have to really figure out what they are, but design this using a block design. All right, so pause it. It's probably going to take you about 7-8 minutes just to read through, and then answering it should go pretty quickly, but reading will take you a little bit. So pause 7-8 minutes and then unpause the video when you're finished, and I'll show you the results. All right, so I kind of set up my diagram here. My experimental units are birds, blocking by breed, blackbirds, starlings, and geese. In each breed or species, I'm assigning both treatments. I just put T1 and T2 because they already told me what T1 and T2 are. All right, and then my steps. Step number 1, number the birds 1 through N in each species. Use a random number generator to assign 50 birds to each treatment group in the species. There's 100 per species of the 3 species. And then step number 3, my random variable, measure the amount of time before eaten. That's another 64, B4. I got a little lazy and abbreviated. All right, today was a bit long. You have an exit ticket in Schoology for today. Our next video will be much shorter, but also a little more difficult. So, hope you did well in your quiz, and I will see you in our next video.